In this video, let us learn about service operation. Request fulfillment, purpose. The team service request is used as a generic description for many different types of demands that are placed upon the IT organisation by the users. Many of these are typically requests for small changes that are low risk, frequently performed, low cost, and so on, e.g. a request to change a password, a request to install an additional software application onto a particular workstation, a request to relocate some items of desktop equipment, or maybe just a request for information. Request fulfillment is the process responsible for managing the lifecycle of all service requests from the users. It is the process for dealing with the service requests. Many of them are actually smaller or low risk. The purpose needed to fulfill a request will vary depending upon exactly what is being requested. Some organizations will be comfortable to let the service requests be handled through their incident management processes. Request fulfillment objectives. The objectives of the request fulfillment process are to maintain user and customer satisfaction through efficient and professional handling of all service requests, provide a channel for users to request and receive standard services for which a predefined authorization and qualification process exists, provide information to users and customers about the availability of services and the procedure for obtaining them, source and deliver the components of requested standard services, e.g. licenses and software media. Assist with general information, complaints or comments. Request fulfillment, scope. The process needed to fulfill a request will vary depending upon exactly what is being requested, but can usually be broken down into a set of activities that have to be performed. For each request, these activities should be documented into a request model and stored in the SKMS. Some organisations will be comfortable letting the service requests be handled through their incident management process and tools, with service requests being handled as a particular type of incident. Note, however, that there is a significant difference here. An incident is usually an unplanned event, whereas a service request is usually something that can and should be planned. Therefore, in an organisation where large numbers of service requests have to be handled and where the actions to be taken to fulfil those requests are very varied or specialised, it may be appropriate to handle service requests as a completely separate work stream and to record and manage them as a separate record type. This is essential if reporting is desired that more accurately separates incidents from requests. Note that ultimately it will be up to each organisation to decide and document which service requests it will handle through the request fulfillment process and which will have to go through other processes such as business relationship management for dealing with requests for new or changed services. There will always be grey areas which prevent generic guidance from being usefully prescribed. Request fulfillment, value to business. The value of the request fulfillment process includes the ability to provide quick and effective access to standard services that business staff can use to improve their productivity or the quality of business services and products. The ability to effectively reduce the bureaucracy involved in requesting and receiving access to existing or new services, thus also reducing the cost of providing these services. The ability to increase the level of control over requested services through a centralised fulfillment function. This in turn can help reduce costs through centralised negotiation with suppliers and can also help to reduce the cost of support. Problem management, purpose. Problem management is the process responsible for managing the life cycle of all problems. ITIL defines a problem as the underlying cause of one or more incidents. The purpose of problem management is to manage the life cycle of all problems from first identification through further investigation, documentation, and eventually removal. Problem management seeks to minimise the adverse impact of incidents and problems on the business that are caused by underlying errors within the IT infrastructure and to proactively prevent recurrence of incidents related to these errors. In order to achieve this, problem management seeks to get to the root cause of incidents, document and communicate the known errors, and initiate actions to improve or correct the situation. Problem management, objectives and steps. The objectives of the problem management process are to prevent problems and resulting incidents from happening, eliminate recurring incidents, minimize the impact of incidents that cannot be prevented. Problem management, objectives and steps. Problem management follows the below-mentioned steps. Problem detection. It is likely that multiple ways of detecting problems will exist in all organisations. These can include triggers for reactive and proactive problem management. Suspicion or detection of a cause of one or more incidents by the service desk, resulting in a problem record being raised. The desk may have resolved the incident but has not determined a definitive cause and suspects that it is likely to recur, so will raise a problem record to allow the underlying cause to be resolved. Alternatively, it may be immediately obvious from the outset that an incident or incidents have been caused by a major problem, so a problem record will be raised without delay. Analysis of an incident by technical support group, which reveals that an underlying problem exists or is likely to exist. Analysis of incidents that result in the need to raise a problem record so that the underlying fault can be investigated further. Trending of historical incident records to identify one or more underlying causes that, if removed, can prevent their recurrence. In this case, a problem record is raised once the underlying trend or cause is discovered. Problem logging. A cross-reference must be made to the incident or incidents which initiated the problem record, and all relevant details must be copied from the incident record to the problem record. It is difficult to be exact as cases may vary, but typically this will include details such as user details, service details, equipment details, date, time initially logged, priority and categorization details, incident description, incident record numbers, or other cross-reference, details of all diagnostic or attempted recovery actions taken. Problem management, objectives and steps. Problem categorization. Problems should be categorized in the same way as incidents, and it is advisable to use the same coding system so that the true nature of the problem can be easily traced in the future and meaningful management information can be obtained. This also allows for incidents and problems to be more readily matched. Problem prioritization. Problems should be prioritized the same way, using the same reasons as incidents. The frequency and impact of related incidents must also be taken into account. Problem prioritization should also take into account the severity of the problems. Severity in this context refers to how serious the problem is from a service or customer perspective, as well as an infrastructure perspective. For example, can the system be recovered or does it need to be replaced? How much will it cost? How many people with those skills will be needed to fix the problem? How long will it take to fix the problem? How extensive is the problem, e.g. how many CIs are affected? Problem investigation and diagnosis. At this stage, an investigation should be conducted to try to diagnose the root cause of the problem. The speed and nature of this investigation will vary depending upon the impact, severity, and urgency of the problem. The CMS must be used to help determine the level of impact and pinpoint and diagnose the exact point of failure. The KADB should also be accessed, and problem matching techniques, such as keyword searches, should be used to see if the problem has occurred before, and if so, to find the resolution. It is often valuable to try to recreate the failure to understand what has gone wrong, and then try various ways of finding the most appropriate and cost-effective resolution to the problem. It may be possible to recreate the problem in a test environment that mirrors the live environment. This allows for investigation and diagnosis activities to proceed effectively without causing further disruption to users. Workarounds. In some cases, it may be possible to find a workaround to the incidents caused by the problem, a temporary way of overcoming the difficulties. For example, a manual amendment may be made to an input file to allow a program to complete its run successfully and allow a billing process to complete satisfactorily. But it is important that work on a permanent resolution continues where this is justified. In this example, the reason for the file becoming corrupted in the first place must be found and corrected to prevent this happening again. When a workaround is found, it is therefore important that the problem record remains open and details of the workaround are documented within the problem record. Problem management, objectives and steps. Raising a known error record. A known error is defined as a problem with a documented root cause and workaround. The known error record should identify the problem record it relates to and document the status of actions being taken to resolve the problem, its root cause and workaround. Also, known error records should be stored in the KEDB. As soon as the diagnosis is complete, and particularly where a workaround has been found, even though it may not yet be a permanent resolution, a known error record must be raised and placed in the KDB so that if further incidents or problems arise, they can be identified and the service restored more quickly. In some cases, it may be advantageous to raise a known error record even earlier in the overall process, even though the diagnosis may not be complete or a workaround found. This might be used for information purposes or to identify a root cause or a workaround that appears to address the problem but hasn't been fully confirmed. Problem resolution. Once a root cause has been found and a solution to remove it has been developed, it should be applied to resolve the problem. In reality, safeguards may be needed to ensure that the resolution does not cause further difficulties. If any change in functionality is required, an RFC should be raised and authorised before the resolution can be applied. If the problem is very serious and an urgent fix is needed for business reasons, then an emergency RFC should be raised. The resolution should be applied only when the change has been authorised and scheduled for release. In the meantime, the KEDB should be used to help resolve quickly any further occurrences of the incidents, problems that occur. Problem closure. When a final resolution has been applied, the problem record should be formally closed, as should any related incident records that are still open. A check should be performed at this time to ensure that the record contains a full historical description of all events, and if not, the record should be updated. Major problem review. After every major problem, as determined by the organisation's priority system, and while memories are still fresh, a review should be conducted to learn any lessons for the future. Specifically, the review should examine those things that were done correctly, those things that were done incorrectly, what could be done better in the future, how can you prevent recurrence, whether there has been any third-party responsibility, and whether follow-up actions are needed. Problem management, scope. Problem management includes the activities required to diagnose the root cause of incidents and to determine the resolution to those problems. It is also responsible for ensuring that the resolution is implemented through the appropriate control procedures, especially change management and release and deployment management. Problem management will also maintain information about problems and the appropriate workarounds and resolutions so that the organisation is able to reduce the number and impact of incidents over time. In this respect, problem management has a strong interface with knowledge management, and tools such as the KEDB will be used for both. Although incident and problem management are separate processes, they are closely related and will typically use the same tools and may use similar categorization, impact, and priority coding systems. This will ensure effective communication when dealing with related incidents and problems. The problem management process has both reactive and proactive aspects. Reactive problem management is concerned with solving problems in response to one or more incidents. Proactive problem management is concerned with identifying and solving problems and known errors before further incidents related to them can occur again. While reactive problem management activities are performed in reaction to specific incident situations, proactive problem management activities take place as ongoing activities targeted to improve the overall availability and end-user satisfaction with IT services. Examples of proactive problem management activities might include conducting periodic scheduled reviews of incident records to find patterns and trends in reported symptoms that may indicate the presence of underlying errors in the infrastructure. Conducting major incident reviews, where review of how can we prevent the recurrence can provide identification of an underlying cause or error. Conducting periodic scheduled reviews of operational logs and maintenance records, identifying patterns and trends of activities that may indicate an underlying problem might exist. Conducting periodic scheduled reviews of event logs targeting patterns and trends of warning and exception events that may indicate the presence of an underlying problem. Conducting brainstorming sessions to identify trends that could indicate the existence of underlying problems. Using check sheets to proactively collect data on service or operational quality issues that may help to detect underlying problems. Reactive and proactive problem management activities are generally conducted within the scope of service operation. A close relationship exists between proactive problem management activities and CSI lifecycle activities that directly support identifying and implementing service improvements. Proactive problem management supports those activities through trending analysis and the targeting of preventative action. Identified problems from these activities will become input to the CSI register used to record and manage improvement opportunities. Problem management, value to business. Problem management provides value to business by providing higher availability of IT services by reducing the number and duration of incidents that those services may incur. Problem management works together with incident management and change management to ensure that IT service availability and quality are increased. When incidents are resolved, information about the resolution is recorded. Over time, this information is used to speed up the resolution time and identify permanent solutions, reducing the number and resolution time of incidents. Higher productivity of IT staff by reducing unplanned labour caused by incidents and creating the ability to resolve incidents more quickly through recorded known errors and workarounds. Reduced expenditure on workarounds or fixes that do not work. Reduction in cost of effort in firefighting or resolving repeat incidents.